Okay, let's get started. So, I was hoping to get the testing done um, last night, but not so much after work. So let's take a look at going ahead and doing a couple of more tests here. So we were able to verify that the basic types work, right? So our um, so the types like integer and string and so forth, we can add them to the dependency manager and get them back out. So let's try um, let's try a slice of strings, or let's try slices. So let's go ahead and create a dependency manager like we did above. Okay. So let's go ahead and create a few slices. So let's start with a slice of strings, and we'll call this string slice. Okay. And I don't know that we need to do anything more complicated than just try it once, right? Because if string slices work, chances are everything else will work. Can't remember if testing for quality, let's see. Invalid operations, okay. Not equal is not defined on string, okay? So, so we'll just do it this way. Um, I think that's all we need to say. Okay, so now we'll go and check for quality. Just do it in a loop. Okay. So if we run this real quick, that's good. Okay. So let's do an interesting test now. So let's go ahead and test. Let's go ahead and test composite types. So we'll start with a struct that has no child structs. And we'll call this basic struct. We'll give it some okay. Now, if we register a struct, what we're doing is registering the type of the struct and getting back a new struct. So what we'll do is we need to register values for foo, bar, and baz. Whoop. Foo, say 100. Okay, so we registered some values, and we're going to go ahead and register a basic, and we're just going to create an empty basic. All right. So let's go ahead and grab it back. Okay, so let's go ahead and run this. Oh, interesting. We failed on our casting. Oh, that's right, because we get back a new instance of it. Okay, so I'm not thrilled with this interface. I want to rethink this because I feel like if we go ahead and do something like, we should get back a pop. I don't think this should be necessary. So let's go ahead and take a look at what we're doing here. Maybe we should be handling type. Maybe we should be saying no. Interesting. So let's go take a look at the let's go take a look at the definition of type. Actually, we can do it right from here. So right, so we want to take a look at type. So what's type? Type is an interface. It's an interface of type, right? So we could register an interface, right? We could register something of type. And just thinking about it, we could do something like oops, that's probably not the place for it. So here we go, get instance. So else if t.kind equals reflect interface if iFace okay is equal to I think we want to say an instance dot if the instance is a type. So we have it. Then we want to do this, right? No, we want to do So what we've registered here is the type. Let's go back to the other project and see if we can do this. So let's go to something. So let's go ahead and clean out the stuff we don't need anymore. So I'm going to clean out this. I'm going to clean out make instance. Leave set by name, set field. We're going to leave get instance. We're going to get rid of this. Let's go ahead and remove these. We can go ahead and gut all this out. I'm really just I'm not worried about preserving this this project, right? It's, well, first off, I believe I have it up on source control, so yeah, I think I've got it on source control. Anyway, it's a Scratch project anyway, so I'm not too worried about it. So if I have person struct and it's got a first name, last name as a string, right? Register, and I want to register a type of, and just create an empty person, right? I think that's how I have to get a person type. I really don't know of any other way to get a person type. Anyway, okay, so we've registered that. Let's just put a breakpoint in here and say so val equals dm dot get instance person. Let's just go ahead and print out a person, and let's create a stringer for person, so it helps. It helps just kind of not driving us crazy with. Well, it just helps visually. Okay. All right, so we've got our person. Let's go ahead and debug this. So let's take a look. Let's get rid of all these. Let's really close at t.kind. So kind is a pointer. So if t.kind is a pointer, what is v? V is a reflect. Well, what is an instance? What if I said v.lm? What would I get back? T, well, what's T? Uh, hmm. What if I tried casting let's see. Let's take a look and see what if we did an instance. So v element value it's an unsafe pointer to an R type. And let's see if we can cast that to So if we just kind of step through this, what's going to happen is we're going to see that it is its own thing. So it's not a struct. It is definitely a pointer. See if that holds. It's a reflect.rtype. So let's go take a look at the reflect package and we can see if we can find rtype. So that's a reflect.rtype. Let's see. That is an R type. It gives us a size. It gives us some packing data. Find a quality. Okay. So yeah, we see it's a pointer to an R type, but it's not a pointer to a type. And an R type is contained within a type. Can we convert Nope, it is an R type. So it is not a type. Can we build a type from an R type? So let's go ahead and go back to this and see if we have a way to get back to type of I. Let's go ahead and see how this is implemented. Return to type. Let's see if that works. Reflect type of reflect dot let's see, so we want v interface. Value error, okay. Reflect as type of v element interface. We get back an R type. What happens if we call new on that R type? So let's use new. So okay. Can't do that. And we can't do that because that's not convertible to a type, it's just an interface. So reflect new. I think this works because result I think we're losing type information is why it's happening. I think we can run it through an interface, so it would understand that it is a type down here. It would totally understand it's a type down here during a register. So let's do this. Let's do d equals, so let's do this. Let's do reflect dot type of okay. Let's go ahead and all right. Let's go take a look at the actual type of the thing returned from type of. Format. So we'll stop it right there. Okay, let's go debug now. So let's take a look at T. T is a reflect R type. So that gives us back a reference. We get that. That gives us back a pointer, so we have to get the element. Get its interface, and then we can cast it to a main.person. Okay. Okay. I don't know, maybe that doesn't work in the debugger, but that should work, right? So we should be able to Let's just go through. So we get the type of the person, okay. We get P equals reflect. So let's go ahead and create a new person off its type. So what we want to do is we want to say interface. Let's go ahead and debug that. And let's see what's going on here. Nope. It did not become a person. I could not cast a person. Okay. Okay. Let's try again. Yes, okay, that became a person. Okay. So let's take a look at what happens in register. Register, we're basically turning it into an interface, right? So we're turning it into an interface. And what is T? T is a pointer to a reflect. What if okay. So R-type's not a public type, so I can't really count on being able to cast to an R-type. But let's see what I've got in here again. Okay. Clean these out. So let's first start looking at an instance. It's an interface and a pointer to R-type. Let's do this. An instance dot reflect type. I can't make that cast because it's a pointer to R-type and not a type. So it's a pointer to an R type, but not a type. So what if I said t.new or reflect? So what if I said v.lm? What's that? It's a value. All right. What's that? That is an R type. Oops. This won't work, but let's take a look and see what we get as an error. Okay, so here's what I think is happening. I think when we register this as an interface, we lose the type information and we can't get this back that allows us to create something off that type. Which is why registering an empty struct work, right? So we could register a struct, and that was fine. But if we register a type, that doesn't work because we can no longer get back the fact that the thing we're pointing to is a pointer to a type. The only thing the type inspection sees that it's a pointer to an R type. So why doesn't... So we see it's yeah, we're seeing it as an interface which has an underlying thing of R type, but it's not a type that has an underlying thing of R type. Like if we go back here, and let's go ahead and clean these out. If we go back here, we see that what did we registered T, right? So if we do reflect type of person, yeah. If we do if you look at T, it's a reflect type pointer to, it's a type pointer reflect R type. If we do T dot value of T, it's an unsafe pointer. Yeah, we're losing the type information. That's what I think is happening. I think that by passing it through becoming an interface, we lose an important piece of information that doesn't allow us to take this back to a type. But I don't understand why. That's the weird thing. So if I do value of so let's say x is equal var x interface and it equals t. Oops. Okay. Yeah, casting that interface to a type causes it, or sorry, casting that type to an interface causes it to become unusable in a weird way. So if I did, of course I can't do reflect.new on x because x is not a type, right? So it's from a type standpoint, it's an interface. It's not a it's a blank interface. It's not a type interface. And if I did this, I can't convert it to type. That doesn't work. Interesting. Okay. If I did what if I did a convert? And I did reflect. What does convert take? It takes a t.type. Let's look up how to use convert. let's look up how to use convert. So via some value, and you convert it to some other value. So reflect value of x. So now x is a value. We do convert. So let's take a deep look into value. No. Nope. 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 Hmm. Okay. So there we're calling reflect type of. Okay, that gets the writer. Okay. Okay, let's see if that panics. Yes, it does panic. Interesting. So once we take the type of person and convert that type to an interface, we can't get the type back. Can we do this? X. Um, can we do this? So let's put a breakpoint here. And let's go ahead and debug it. So can I just do an instance dot no, I cannot. No, I cannot. So here's what's going on. So if I take T, I get T as a type of person, and I go ahead and cast it to an interface. So I'm storing it now in a value that in a variable that's a type interface. I can go ahead and cast it back. Okay. However, if I register it, so in fact, let me just do this. If I register T, and then I'm putting it into a map of strings and interface. Okay. If I register T, I'm putting it in a map of strings and interfaces. When I go get it, I lose the important piece of information that it is a type. So what I could do is I could do this, types. Like this. So this is a map of types. So if equals item, so if it's a type, so let's see if that works. Let's put a breakpoint there. Okay. So now what I'm doing during registration is I'm checking to see if the thing I have is a type. So let's step over that. And I do detect, okay, I do detect it, so I put it in types. Okay, now, let's continue. Let's get rid of the convert that's causing the panic. Okay, so let's do this. Get instance. Okay, so this case, so let's take a look. Okay, so in this case, I don't have it registered under an instance. So just quickly hacking it together, I can say if some type so in this case it's not an instance of a thing, it's not a type. So let's go ahead and return nil. Else reflect new type. Okay. Else it's a kind of struct. You just turn okay, so now let's take a look at now let's run this. Why is that panicking? Oh, it's a nil map. Okay. So okay. We need to do one or the other, not both. Okay, why is it panicking? So we're calling set field on the result, which we're calling set by name. And set, let's go ahead and put a breakpoint there. And let's continue. Okay, so what do we have? We have reflect.value, which is item. That gave us field. Val is nil. Set field. So we look up so inject from is nothing. So there's nothing registered with that name, nothing registered field, first name. Okay, set by name. And so item which is oh, okay. All right. So I think the problem is we don't have anything set for first name, last name. Let's go ahead and panic out. So my guess is we need to handle the zero case. It's because we don't have first name, last names list. So let's go ahead and set. and run it now. Yeah, okay, so we just didn't have a value. So we need to handle 0 case, so we don't handle that. Let's go to the 0 case. So what do we, let's take a look at get instance. Maybe we just need to do instance interface bool return did that. Okay. So what if we did that? Oh, we don't use it. If not found, so we pass an item, field name, and reflect so we inject the 0 of that field. Okay, so let's go ahead and run it. So that works. What happens if we comment these out and we don't have values for that? We should get the 0 for the field. Yep, okay, that's it. Okay. All right, so I need to integrate that with my code later to basically say, yeah, this needs to be cleaned up, but basically what I've done today, just to go over it again, is I can't stick types in this map. If I do, I lose the type information about, ironically, the type, and then I can't use it to create a new instance. And so what I want to do is I want to be able to register the type of a person to generate a new person dynamically. But I also want to be able to say Ed, and Ed is a person, and first name is Ed, last name Smith, um, DM Ed, oh, so I do val right? So right, okay. So I want to take val dot all right, so what I should get back is Ed. All right, so this is what I did today. So if I register a type for like person, I get back a new person from that type. If I register a struct of type person, I get back the struct I registered, and I think that's more reasonable behavior. And what makes this possible is that we do two things. We keep track of types separately from values, and we return values when we need to. But we return types well, we have to sort types separately so we can recover we don't lose the typing information. That lets us know it's a type to be able to construct a new thing from the type. So really this just becomes this. Well, not really, because really what we need to do is be able to be able to go through that return that person and check to see whether or not a field value is set. So we need some sort of conditional set that says if we get a struct back and we have fields in the struct that aren't set, they're essentially their zero value, we make an effort to set them. So if we get back a struct, we have to do something like this. Now this works here because when we construct a new whatever this type is, this is a reference, and so the fields are settable. And so we just have to make sure the fields are settable here, but we have to do basically the same thing, except when we call set field, we only want to set field if the type field is a 0 value. But of course, it could be a 0 value, right? So it would be perfectly legitimate for me to have the value 0 as a member of a struct, or a blank string as a member of a struct. That would be perfectly legitimate. Maybe if the maybe the rule should be if the inject tag is present and the value is 0, inject it. So maybe that's the rule. Maybe the rule is if we have an inject tag on the struct and the value is 0, we go ahead and look up that value. Well, anyway, that's enough for today. I'll get back to it tomorrow.